Hi everyone. Thank you for joining us and attending this webinar covering ETAP's Intelligent Single-Line Diagram, or iSLD. ETAP's iSLD is a multi-layered one-line view of the digital twin that includes advanced functionality and awareness of the device's characteristics and system behavior. It is an active blueprint in the foundation of your digital transformation journey. I'm going to show you how to use many of ETAP's tools to easily create and modify your single line diagram so you can visualize, collaborate, and analyze electrical networks. ETAP's iSLD is designed to easily display analysis results, real-time system information, and estimated data to automate, validate, and manage AC and DC power network systems. The Intelligent Single-Line Diagram visualizes data in any combination of voltage, phase, frequency, measuring units, and standard for any application and industry. In power engineering, a single-line diagram is an electrical drawing representing the electrical devices or assets of a power distribution system. The electrical diagram is represented by symbols and describes how these electrical devices are connected and related. Sometimes a single-line diagram of an electrical installation is also called a one-line diagram. The single-line diagram provides a fundamental representation or a blueprint of a three-phase power system. As the term suggests, it's a one-line diagram that uses a single or one line to represent all three phases. Creating a one-line diagram is the first step in preparing a critical response plan, enabling electrical personnel to fully understand the layout and design of the facility's electrical distribution system. Whether a new or an existing facility, the single-line diagram is the roadmap for all future testing, service, and maintenance activities. An intelligent electrical digital single-line diagram is a digital single line that includes advanced functionality and awareness of the device's characteristics and behavior. It dwarfs simple graphics by being able to adapt to the connection changes, unlike a conventional drawing. A digitized SLD is the foundation of the electrical digital twin that can be leveraged not only to communicate the network connectivity and asset information, but also as the basis for power system analysis from design to operation. Keeping a digital twin up to date is very important and provides many benefits to the engineering and operations team. Maintaining compliance with applicable regulations and standards, such as NFPA 70E, Article 205.2, which is here locally in the U.S., mentions a single-line diagram where provided for the electrical system shall be maintained in legible condition and shall be kept current. You can use ETAP to easily keep a single-line diagram up to date. Print out diagrams when necessary in order to comply with this standard. An accurate single-line diagram will further ensure the safety of personnel work. Electrical safety consultants will typically ask for the latest single-line diagram for OSHA. Therefore, an updated single-line diagram is the most important fundamental material for any facility. Based on NFPA 70E on electrical safety standards at work, several studies, assessments, and evaluations require the need for us to update the single-line diagram so these activities can be carried out. Often, decision makers feel that they do not need to update the electrical installation diagrams or even consider them essential. Many industrial and commercial facilities operate without accurate single-line diagrams. These conditions may not be considered vital until they encounter real problems or losses due to not updating or inaccurate electrical installation diagrams. However, you can reduce downtime and minimize production loss as the single-line diagram eliminates guesswork when performing what-if studies and finding the optimal strategy for any power system recovery. If the single-line diagram is not kept up to date, it is quite complex and requires some level of guesswork to ensure that the what-if scenarios you're performing to get out of unplanned outages is going to be the right decision for your facility. You can utilize the single-line diagram for operation intelligence as well. The single line is used as the digital twin which assists operators in making the right decision when investigating events or planning for future upgrades. The digital twin validates the design and operation models and provides an accurate forecast required for optimization maintenance strategies. Let's take a quick look at the ETAP ecosystem for digitizing your electrical system and creating this digital twin, and of course sharing this information at the same time. Within ETAP software, you can build the single-line diagram and enter all the characteristics of the electrical system, including protection, cable pulling, underground raceway systems, and many others that go into this digital twin besides just your single line diagram. However, many times we have project information contained in other formats and files. With data exchange capabilities, you can import data or the model using AutoCAD DWG, save time using the bidirectional interface with Revit for BIM models, or even change data using various XML formats including SIM and CGMES. If you have the data in Excel, you can easily import the data directly in each device within the single line diagram. You can also exchange data with GIS systems or geographic information systems such as Esri and ArcFM, and use a variety of these sources to import the data and build a single line diagram automatically. Shortly, I will cover how to quickly build the intelligent single line diagram using ETAP tools such as AutoBuild, and also how to take advantage of templates you may have created from past projects. During part 2 of this project management series, we presented NetPM and the most efficient way to share the model and data between different engineers, managers, and operators. NetPM is a cloud-based service that allows the data to be sent from one ETAP client to others. NetPM is also used when personnel are out on the field collecting and validating data with the ETAP app, which was covered in part 1 of this same series. Users can synchronize the ETAP app with the main ETAP project files, which also communicates with other ETAP solutions such as eProtect. eProtect is a centralized asset management and fault analysis system that utilizes a web interface to view electrical information saved within ETAP or pulled directly from the devices. eProtect connects to the facility, retrieves relay settings, downloads waveform captures, stores them, and exchanges the information with ETAP, so this information can be used for any analysis and validation. Through NetPM, information can be shared with engineers using ETAP, field data collection personnel using the app, operators with ETAP SCADA, planners using GIS. Any changes sent from different individuals can be propagated back to the main project file and redistributed to all applicable members of the team who have the security rights to this specific information. But first things first, let's cover how to build an intelligent single line diagram and go over all the tools ETAP provides to quickly build and manage the ETAP iSLD. Unique to ETAP is the transformation from a flat database into a multi-dimensional database. This eliminates the need to make hundreds of copies within the same project. The multi-dimensional database allows for unlimited graphical presentations, status configurations, revision data layers, and operational parameters within the same project file. Using the concept of presentation, status configuration, and revision data, you can create numerous combinations of networks of diverse configurations and varying engineering properties that allow you to fully investigate and study the behavior and characteristics of the electrical networks using a single database. Incorporating multiple generation categories, loading profiles. Generation categories are essential today with the continuous expansion of renewable energy systems. Multiple scenarios are required for organizations to comply with grid codes, optimize their energy use, assessing the impact of change in weather conditions, while facilitating safe and reliable power system operations. The key here is to use a system with unlimited scenarios. Avoid the risk of project delays due to the simple fact that the software used limits the scenarios and requires multiple copies of the same project to account for these various conditions. The key features we're going to focus on today include AutoBuild and smart alignment, themes and managing layers for results and properties, color contouring, and equipment and reference design templates, so you can take advantage of past projects and utilize them in future so you can save lots of time removing the need to duplicate any work. Now, let's go into ETAP and take a look at how to apply these features. Many of us are familiar with the traditional method of building a one-line diagram, or at this point we can call it old school. Essentially, I click the utility, drop a bus, I just click the devices that I want and move them over to the platform manually. I can click a transformer, connect to the upstream bus. This is a very tedious and laborious process and takes a large amount of our project time. So you essentially bring a motor And I can drag that, connect it to the upstream bus, and if I'm missing protective devices, I can insert these protective devices in line. It's very common practice. Many of us have built one-line diagrams using this method before. Now what we need to use is AutoBuild. So enable AutoBuild from the toolbar, and within the AutoBuild toolbar, we have voltage levels that are only applicable for this project. So when voltage propagation occurs as you're building the model, it knows what voltages to apply. So in this case, I'm going to start with my source, but from this point on, I click a bus, I click a transformer, and as you notice, as I'm selecting these devices, the one line is automatically built off to the side for me. I remove all that time wasted from dragging and manually connecting. Now I select my transformer and click the center alignment, and now I automatically align those 3 loads to the transformer. And instead of moving one breaker into position, I highlight all my loads, click the breaker one time, and we see that it inserts upstream to all those loads. I can extend the bus, select a specific point, and continue building my model. This saves hundreds of hours during the one-line diagram creation portion of your project. Even for relays, I click the CT, then I click the relay, and it's automatically connecting for me. Now let's say you have annotation issues. Let's say that the annotations are pretty sporadic and messy. We'll fix one of them. So I'll align my annotations for lump 2. I'll use the center alignment tool. I can automatically align them left, center, right, or space them across vertically. And this center aligns them to each other. I'm going to save my alignment position for lump loads. So I right click, go to info annotation and hit save position. Now I'm going to use my keyboard shortcut shift right mouse click. When I use shift right mouse click, it highlights all the lump loads. And when I apply my annotations globally, it fixed all the lump loads. And if you have one that's isolated and you need a fix, I use my keyboard shortcut letter I. When I click the letter I, it automatically fixes the annotation for that specific lump load. Speaking of keyboard shortcuts, I highly recommend everybody gets familiar with the keyboard shortcuts within ETAP. They make modifying and manipulating the one-line diagram so much quicker. So if you go to Help Search, here we have a list of all our keyboard shortcuts. Take the time to print this out, save it, become familiar, and utilize these whenever you're doing your next project. I'm going to cover some of my favorites now. One of the keyboard shortcuts I like to use when viewing a large one-line diagram is F11. And essentially F11 expands the screen to just focus on the one line. It removes all my toolbars. The system toolbars removed, all the mode toolbars removed, and the study mode toolbars removed. And I can just focus on the one-line diagram. So that one's very helpful. And I could just hit F11 again to come out of it. And then if I have multiple presentations, so within ETAP, I can have different presentations, as we talked about when we talked about the multidimensional database. I have a relay view here where my relays are shown. Originally they were hidden. And then I have another presentation that color codes by voltage on a black background. And if I'm using these for different purposes, I can simply use Control and an arrow to dock them. So just like a Windows application that you might be familiar with, or Adobe, many of them have this shortcut. I can use Control arrows and I can move the windows to any particular location that I want quickly using that keyboard shortcut. And so those are two common keyboard shortcuts I use when I want to change the way I'm viewing the presentations that I'm using. Next, I'm going to use these two presentations to do a quick what-if analysis. So I have these two side by side. I'm going to run a load flow, and I'm going to compare these two projects, one with the capacitor on and the other off. And one of the keyboard shortcuts I like to use in this case is T. So when you use T, you can open a breaker or open a switch, and all you do is toggle with T back and forth. I highlight the equipment, I hit T, and it closes. So that's a quick one for me. I can pick one element or the whole branch. I hit T, I can run a load flow. I view my results. Turn off the data block in this example. We'll cover data blocks shortly. And on this one, I'm going to copy from normal with the capacitor open. I'm going to call it cap closed. I'll set my study view presentation to cap close. Use T again to toggle closed. I can run my load flow and instantly compare side by side with a quick configuration change and do quick what if scenarios and look at the results without creating any new databases or project files. I can simply use the same project, the same one line, one with relays hidden and the other with the relays exposed, and then we can quickly compare the results of these two different conditions. And you can easily manipulate your model again in toggling all your protective devices and switching using the keyboard shortcut T. Now expanding this one line, what you see here is our composite network. So the composite network is just a way to consolidate the one-line diagram so you can put an unlimited amount of layers and elements in your composite network. They're nested, so you can see all my composite networks in this view, in this list here. I can select them, so you can create substations, you can consolidate MCCs, just so you don't have one large one line taking up the whole main platform. And I just double click and we can go unlimited layers deep. They're still electrically connected. So you take advantage of composite networks to consolidate different views and make your one line easy to manage. Let's say I have these motors. I have motor 9, 11, and 12. And motor 9 has the correct data, motor 11 and 12 are incorrect. So I can highlight all three motors. My reference device is the one with the bracket, so I'm going to use control left click to change the bracket. And then I can say Shift C, and when I say Shift C, it's going to ask me, are you sure you want to replicate the properties of motor 9 to other selected elements? So this allows me to copy the properties from motor 9 and paste them to all other highlighted elements using Shift C. When I say yes, you'll see that the data from motor 11 and 12 now are received from motor 9, and all of this data was pasted over. So this is our copy data and paste to many devices. So you just have to highlight the ones and select the bracket, and it's easy to copy and paste the data over to different elements. And if I want to add one more, I can highlight this branch, Control-Shift-Drag. Control-Shift-Drag duplicates that motor, that whole branch, and I've created a copy from one of my existing one. Again, that's just done by highlighting and clicking Control-Shift, and then I can drag it over and duplicate that equipment along the bus. Another tip and trick that a lot of people may not know is I can double click the ID and change the ID straight on the one-line diagram. So I don't have to open the editor. I can do it directly from the one line, directly from the interface, and you'll notice it updates the editor automatically. So you no longer have to double click the motor, open, and make the change in the device. You can simply be in your presentation directly and double click the ID itself, making it editable and changing the name to your preferred name of this device. There are other tools that we have to clean up the look and feel of your one-line diagram. So on sub 3 switchgear, I have a remote connector. If I double click the remote connector, it shows the other side of the connection. Now these are electrically connected, but they're split into different composite networks just for the sake of viewing. Now you can either use a remote connector for any devices right here from the edit toolbar, or for buses in particular, I can right click the bus, hit split. I select to split the bus at a specific location, and now I can move. This is still electrically connected, it's still switch 3 switchgear, but there's a splitting point just for visual representation. And in this example, I've decided to visually move and isolate all the connections that have single phase equipment. So from this portion of the bus, I have tap outs that go into my panel boards in single phase, and I just wanted to move it off to the side just for visual clarity. And you can imagine if this was an extremely large project, how these tools would be very beneficial. And if you change your mind and decide you want to reconnect, Very easy. I can just touch the two endpoints together and it automatically reconnects for me. And for additional cleanup, let's say you have misalignment between devices. You can simply select each device or rubber band the entire device, picking which one your reference point is, right click, and you have a list of alignment tools here. I'm going to centrally align them from the breaker, and it automatically fixes the portion that you've highlighted against the reference device, which is identified from this bracket. So whenever you need to clean up your tool, whenever you need to clean your one line up, right click, go to alignment, and select the applicable alignment tools for optimal cleanup. Now we also allow you to automatically clean up motor control centers, for example. If I have these portions are all misaligned here, I can click on the bus and go to my toolbar here, and then from AutoBuild toolbar I have horizontal and vertical alignment or just horizontal spacing, but in this case I picked the bus horizontal and vertical alignment, and it automatically spaced them out horizontally and made them the same length. I previously defined my spacing in AutoBuild, and I prefer to use that, so I'm going to turn AutoBuild on, select the bus one more time, and then use the automatic spacing defined in my AutoBuild rulebook editor. Now I'm going to run my study because I'm getting ready to print. Let's say I want to print sub-3 switchgear with my results and this low voltage bus. I'll run load flow. And for any result that I want to quickly move to the other side, I can toggle by using my right mouse click. So I right mouse click to hit toggle position, and I can switch the result to the other side of the branch. So if you are compressed with the one line and you didn't horizontally space your equipment and you have results overlapping, it's really easy to right click any particular result and switch it to the other side. Thus far we've talked about building a one line using the inherent tools within ETAP's edit toolbar. Now if you have a one line diagram in other softwares, I suggest going to the data exchange menu and take a look at all the options provided to import and or bidirectionally interface ETAP with other applications. AutoCAD, for example, as we talked about earlier, if you have AutoCAD or Revit, you have a bidirectional interface with Revit, and you can bring the one line directly and make any changes with an ETAP and export back to Revit. Also, if you have software in other legacy programs, you can also import from different legacy software to upgrade your model to an intelligent single line diagram using ETAP. As we built this model previously, if I recognize that this model I've used consistently in other products, I can highlight this, and here on the AutoBuild toolbar we have templates. So I can highlight the portion that I want to save as a template. I click Save as Template. I can identify it and just call it low voltage bus if this is a common application and design for me. I save it in any location that I want, and now I can share this low voltage bus with anyone within our organization, or I can just send the file and use it in any project. I never have to rebuild it. And when I go to select this template, I can pick templates or defaults. Now templates brings in all the data that we had saved when we constructed it in this project. So if I want to bring it in and I want motor 7 to still be a 200 horsepower motor, and I want load 1 to still be 280.4 kVA, I select the templates when I bring this into my project. Now defaults is typically set to 0. Everything is zeroed out and blank. So if I select defaults, it brings in the one line with no data, and then I can add my data for that applicable project. Now before we get started on any project, if you go into the folders, ETAP provides a large list of templates for you. So if you're working on a healthcare facility, for example, you can take advantage of the templates we've provided before you get started. Or there's a few protection systems in here. So if I look at a typical motor protection design or transformer protection design, I can take advantage, bring these into my one-line diagram, and then add data and build upon them. So I don't have to do everything from scratch. So go ahead, go into the templates folders, take a look at everything that's been provided, and take advantage of any of the templates that we've provided, or build your own and utilize them in any such project. Doesn't have to be the same one you're in. It can, but it can definitely be any new project you're working on. You can browse and again save them in any location, and select them from all the team members building templates and saving them. You can take advantage of them in the future. I can simply click apply, and this one-line template is provided for me. Color coding your one-line diagram comes with a variety of benefits. Allowing themes to each of your presentations provides additional information that is easily identifiable just from altering the look based on the options provided. You can select colors based on phase, voltages, area, specific feeders, grounding, and earthing. Many other additional options are also provided within the theme manager. This presentation we set with a black background, so I can change the background and some of the themes from this pull-down menu, and it's color-coded currently based on phase. I can quickly change that to voltage, and then I identified the voltages from the color coding. Now I can manipulate the color coding from the theme manager, and right now it opened to voltage, and you can see each voltage level and identified by the specific color assigned. I can go to 3-phase and single phase and dictate how I want to color code each type of equipment. Examples such as being energized or de-energized, faulted bus coloring. And speaking of faulted bus, when I fault a bus for short circuit, currently it'll show the bus as red. But if I want to show it based on symbol, you can switch from a color-coded faulted bus to a symbol. And a lot of people do this because maybe they have a printer that's black and white and they still want to identify when they print the one-line diagram, they want to identify the faulted buses from a symbol rather than from a color. So you can make that change here as well. Within the formats tab, now we're looking at precision in units. So you can set for each result, you can set, right now we're set to power, voltage, current as the top 3, and you can go through and take a look at all the results in ETAP, and you can set its specific unit for that result parameter, and then the precision you want to see on the one-line diagram. So you set how many places after the decimal point that you want to display. And if you run a calculation and the result is 0, you can click hide 0 values so that that result is not shown at all. So here's some options within the theme editor. Now in this case you can apply it globally to all your presentations or the one you're currently on. You can save as a particular theme that you set so you can pull it up in the future. Here's 4 that are provided by ETAP by default. And then the last one I want to look at is layer. Layer allows us to hide or display any of the devices on the one-line diagram. So for example, let's go into the view we had with our relays. And in this case, if I wanted to quickly hide the relays, and in this case, I want to hide my relays and CTs. So all I have to do is uncheck the relay and CT, click OK, and you see that those devices are automatically hidden on this presentation. You essentially can hide them from your view and focus on the devices that you're trying to evaluate at the time of that particular study. Another option I like to use is if we add equipment. Earlier we added this motor, and let's just say this motor was added for future. So another option I like to take advantage of within my themes is set my state to future on this device. So I look at this motor as future, and then in my theme manager, I want to set all future devices to not show. So I'm setting 100% transparency so they no longer show on the one-line diagram. And you see now that motor that was set to future is hidden on this base revision. And then if I go into a future modification, I can bring that motor back to show in that revision. So I can come in here for modification 1, unlock this from base, put new. Now it'll show, and it also shows in green because this motor is different from my base application. So if you make a change in one of your revisions, whether it's a data change or a state or service change, you'll see the color coding in green within that revision. And if I go back to base, you'll notice it's still hidden because in this base layer, it's set to a future state. So that's very important when it comes to adding new equipment into your model. Not only can we color code the presentation based on input data and graphics, we can color code based on results. Under the Tools menu, select the options contour. From the options within the contour settings, we can define the color map that we'll visualize after running a study. So in this case, I'm looking at bus voltage, and I'm going to color code the one line based on a maximum value, minimum value, mid value, and minimum value. So any issues of under voltage under 98%, I'm going to show in a red highlight. I'm going to fill the whole background and apply the alert on top of the entire length of the bus. So I save my conditions, and once load flow is compiled, you see the results. You see the voltage conditions here as I selected. So we see here, if you have a large one-line diagram, this helps identify. It makes it very apparent where your problems are located. So in this case, I can zoom into a specific area, and I see that this bus under voltage condition is under 98% as we set. Now this value is user defined. I can definitely set it to 97%, 95%. Whatever value I set as my minimum condition is very easy to identify when I enable contouring. Another method of changing the look of the one-line diagram within the Tools menu is our Symbol Substitution editor. So if I go from Tools, Symbols, Global Substitution, I activate the Symbol Substitution editor. Within this editor, you have a list of devices with different options. For example, charger, high voltage circuit breaker, low voltage circuit breaker. In this case, many of us are familiar with the standard default ANSI look of a high voltage circuit breaker, but if I wanted to make a change and make the graphical representation similar to what you might see on a SCADA screen, we can do that. So we see that this is the new symbol, here's what's currently used. I can substitute the new symbol with what's currently implemented, and on the one-line diagram you see that the high voltage circuit breaker symbols have been updated. So essentially you can do this for many of the devices included in the Global Substitution editor. The properties and results displayed on the one-line diagram are user-definable as well. If I click on any of the active data blocks within my project, I open up the data block editor. Another way to access that editor is through the data block toolbar. So from the data block toolbar, I can open the data block editor, allowing me to customize any of the properties, results, or real-time tags that will display on my one-line diagram. I can filter the selection of devices by device type, and I can also filter the properties from the studies. So if I wanted input data only for load flow, short circuit, and arc flash, I can filter all the properties accordingly and select the ones I want into the table. Once the data block is selected and identified, you have options to change the font of the values and content. For global, this allows you to show any results selected within your data block to be displayed regardless of the study module that you're on. I've previously added short circuit results to the bus of my load flow data block. So in this case, I have it set to global, and when I run load flow, I get my load flow results, and I go to short circuit, and you see that I have my short circuit results along with the load flow results in the particular data blocks because they are set to global. If I change this to local, then you will see my load flow results will automatically disappear, and only my short circuit results are active due to it being a local data block in short circuit mode. This allows for an easy way to display results from different studies within the same presentation. Now, they can be globally turned off and on from the data block toolbar. You have the option to show connection lines. If you move your data blocks to specific locations and you want to show which device they belong to, you can turn on connection lines quickly, and that'll identify the data block with the appropriate element. And we also have tooltips. So in some instances, you may not want to see the entire data block. You can quickly hide the data block for this transformer, and at any time, you can see it from a tooltip by hovering over that device. Now, if I right-click on the transformer, I can easily bring that data block that I hid right back to the one-line diagram. Once you have set the theme, data blocks, symbols, the overall look of your presentation, and you're ready to print, you can enable the page break view on the presentation, which shows a dashed line mockup of the page size from the printed options you've selected. So I can move different components into a different page and make sure everything from the data blocks to the one line and results is included in the printout. The size of this page setup is defined by your selection in the print setup editor. So I can select the paper size, orientation, and that will dictate the page setup break within the one-line diagrams, making it very easy for you to print and include all the necessary components in the printout. We have now learned about various solutions to build a one-line much faster, drastically shortening project timelines. The ETAP Intelligent One-Line expands to a digital twin, which becomes the driving force behind operation and automation decisions and optimization techniques. Manage the project using different graphical representations of the facility and customize results, properties, and plots to create deliverables based on customer and project requirements. Compare scenarios from past events received from the ETAP historian, scenarios from present conditions from the ETAP SCADA, or future conditions with predicted and forecasted data. And share information between personnel on the field, engineers, operators, and managers using NetPM in the ETAP app, printed deliverables with engineering data, or automatically convert single-line data from legacy software and standard formats directly into ETAP, quickly building your one-line diagram. Thank you everyone again for attending this webinar to learn how to efficiently create and update your ETAP Intelligent single-line diagram.